Alright, the first part was the matching part. So what I would wanted you to do was to try to like look at the odd, the even, is it both going up, both going down, one left, one right, and then look at how many zeros it had. Yes, you could put them in your calculator, but I wanted you to kind of get a feel for describing these things. Like for instance, this one. This is an odd function. 3 zeros. Your exponent is 3. And it had A was positive because it was down on the left, up on the right. So it kind of narrowed it down to one of the ones with a 3 and a positive. And sometimes you may have narrowed it down and then had to go through it. This one was an even one, was an odd one also, was an odd one also. And it had 1, 2, 3, 4, 5 zeros. So go for the one with the 5 in it. And positive A, and check from there. Were you guys okay with this part? It's good to be able to start describing these so that you can see what you're looking at. Parabola, turning down. Okay, so you know you have a negative with an x squared, 2 zeros. Here's an odd function again, but it's going the opposite way, so it's negative. Here's an even function for E. They're both going down, so it must be negative in front. And it has 4 zeros. This is your double zero. So these were kind of nice. This was a line. Didn't turn anywhere. Equation of a line. Is it still a function? Mm-hmm. Okay. This one, G, a little bit crooked looking, and G is missing a couple of your zeros. They're probably imaginary zeros, unless we fine-tune it in the middle and see them passing through. And the last one, parabola turn going up, positive A. Okay. Good for those? All right. Honestly, how many of you just put them in your calculator? Okay, so you recognize the graphs. Start trying to, take them apart. All right, for this part, you just have to describe these. What did your directions say? Okay, describe. You're just describing. So first we have an even function. Your highest degree is 4. Your leading coefficient is positive, so that they're both going up. Up on the left, up on the right. This one, 31, watch where they put the x squared. The x squared is the last term. If you want to rewrite this one, rewrite this one. Rewrite it. Your first term, x squared, leading coefficient is 2. I'm sorry. The highest degree is 2. Leading coefficient is -3. They're both going to go down. Down on the left, down on the right. This one, even though it has a divisor over here, it's still looking at the highest one. Your highest degree is 5. You have an odd one. It's positive. So you're down on the left, up on the right. And your leading coefficient is, it should say, is this supposed to be a 5 on yours? 3. So this should say 6 over 3. Which is 2. I must have, well, it's 5. So it's odd, down on the left, up on the right. Just so that you get a feel for these things. This one also, you're going to have to distribute, just to find your leading coefficient. So your leading coefficient is negative on an even function. So they're both going down. There's your parabola, both going down. Down on the left, down on the right. Good so far? Describing is half the battle because a lot of times you have to start sketching right from what you described. Okay, here were your zeros, right? These were your zeros. This is what's going to help you just sketch your graph and see where it's going through your x-axis. The first one, highest exponent is 2. You have 2 roots. So at the end, when you come down to your x equals, you should have 2 for those. Those were your perfect squares. X plus 5, x minus 5. We set it equal to 25. Take the square root, plus or minus. That's a multiplicity of 1. Multiplicity means, like your double root would have a multiplicity of 2. We're using it twice. A negative 5 and a positive 5, we're only using it once. So really the multiplicity comes in on your doubles. And from that, we could sketch. We know the rest of this. We know this is a parabola. A is positive, it's opening up. So as soon as you get your pieces, you know this part's going up. Somewhere down here, it's going to turn. So you have an idea of where it's going, what it's going to look like. Like yesterday, we knew that the little loops would not be even because it wasn't symmetrical. We didn't know how far down they'd be, so we had to sketch for it. Stop me if you have any questions. Number 51, that was a trinomial, and it factored into two perfect squares, t minus 3 and t minus 3. So you have one root of t is equal to 3. That's your multiplicity of 2. That's a double root. Do you see it here? It stays on the x-axis and doesn't go through. That's when you did in Algebra 2, you looked at which quadratic things and you decided to say, you described your roots where they were going to be. There were two irrational, two equal. These were your two equal ones. 53, again, two roots. I should get two x's. Trinomial, factor them. Multiplicity of 1 just because they occur once. And those are your roots. So again, you know this is a parabola. It opens up. Once you get your roots, you can pretty much sketch your parabola in. 55, you had to factor out a t. But still 3 is your highest exponent on this one. So you should get 3 roots out of this. And this one factored into a square, so that was your double one. It goes through the 2, it goes through the 0, bounces off the 2. That'd be a cool one to graph because 3 says positive down on the left, up on the right. Here's your 0, here's your 2. This is a duplicate. At the end of this is going up, this guy's going down. So here's the problem. This can't go through this axis because it's a double root. It's got to go like this. So do you see how it hooks up? I mean, that's the best way we could graph it. Are you trying to graph these without your calcs? Just by the roots and stuff? No? Not daring or not caring? Both. Okay. Last one, it had a fraction. Factor it out. If you wanted to, you could divide you could multiply, once you set it equal to 0, you can multiply every term by 2. Get rid of your denominator. But as long as you set it equal to 0. Excuse me. So we get rid of the 2. We grouped it. And yeah, that was kind of a messy one. I completed the square on that one. To get to the roots. That was a messy one. That one you couldn't be factored, so if you wanted to, you could use your quadratic formula. I just completed the square to find the roots. And again, it has a fraction when you complete the square. God bless you. If you used your quadratic formula, you would come down to these. You'd come down to the same roots. Good? Okay. Now, today, we're going to continue with Why in the back? Can't find anything else to do but talk? Start working on the problem then. Okay. Today we're going to sketch and describe again. tell me one thing about this graph. Okay, Anthony says it's even. Yes, even exponent graph. Not an even function, but an even exponent. So the end behaviors are going up. How did you know that? Because the leading coefficient is positive. Good. The leading coefficient, positive. Good. Okay, Kyle, tell me one thing about the graph that Anthony did it. There's 4 zeros. Okay, there's 4 zeros. All right, so let's find our zeros. Our leading coefficient we know is positive. Our end behaviors are going up, and there's 4 zeros. So let's find our zeros. Jonathan, how should we find our zeros?
So we'll take out x.
Okay, so we're going to set y equal to 0. And we're going to factor out an x squared. Good. Then what? Good. There's your perfect squares, x plus 5, x minus 5. Good. So this guy, what's this guy called? Double root. This is your multiplicity of 2. That's just because it's a double root. Square root of 0 is only 0, so what is this double root going to cause this to do? Bounce off the x-axis. It will not go through the x-axis. Good. That is always good to remember. Okay, so now we're going to sketch. We start with our roots. We have a negative 5, we have a positive 5, and we have a 0. Our end behaviors, they go up. The 0 can't pass through the x-axis. It has to bounce off. It's either going to bounce off like this, like a U, or it's going to come down here. These guys, these roots, where do they have to go? Down. They have to go through the x-axis. They're not double roots. They have to go through the x-axis. So what do you think this makes? A W. Good. And from here, we're going to talk about all your concavities. Symmetry, you think? You think symmetry? Because of your negative 5 and your positive 5? So this could be an even function. This could be an even function. And let's check to see if this is an even function. So if it's an even function, I should be able to replace the f with a negative x. So yep, it is the exact same. So even function, a reflection over the y-axis. Good. Okay. What else can we say? We found our minimums. So let's have you graph this in your calculator and find me your minimums and your maximums. Let me label this, A and B. Are they relative or absolutes? Absolutes. It's absolutely the lowest point. Absolute minimums, point A and B. How about C? What is C? A relative max. Now, with our exponent of 4 minus 1 is 3, we should have 3 terms. 1, 2, 3 terms. How many inflection points?
What's that? Under the word even function, like in the beginning of the equation?
F of negative x. Sorry. Once my pen goes off, then I can't go back over it because it'll never be on the same spot. And it never hits the same spot. So we said 4 zeros, minus 1, 3 turns, 1, 2, 3 turns, minus 1, 2 inflection points. So in a minute, we're going to find our two inflection points. But first, we're going to find your absolute minimums and your relative maximums. This you would need your calculator for. I mean, you could probably go to 2.5 and try with the y value with x of 2.5, but you can use your calculator for these. Because we had symmetry. But might not be it. So where are our absolute minimums?
Negative 3.536 and negative 156.25.
And negative 156.25. Okay, so that would be A, and the B would be positive. Good. Name on it. Okay, 3 decimal places. Remember your 3 decimal places. Okay, so now, how about your relative max? What's that at? What's the 0 up there? This is the 0 right here. Didn't we have a root of 0? So what should this point be? 0, 0. Okay? Let's talk increasing right now. Give me the increasing intervals. Negative 3.536 to 0. And where else? Positive 3.536 to infinity. Okay. And the decreasing? Negative infinity. Use the x values, good. And where else? 0 to 3.536. Now, this should take care of your whole domain. What is the domain for this function? Bless you. Bless you. What's the domain? All real numbers. Good. So your domain was all real numbers. What's your range? Negative 156.25 to where? Infinity. Good. Look at all you know about this graph. Who would have thought? Who would have thought? Last year you looked at this, you just stuck it in your calculator, you drew a graph. Look at all you know so far, and we know even more. So we got our increasing, decreasing down. Now we're going to find our concavities. And to do that, we're going to have to find an inflection point, because some of them are going to share. So if we come over here and we look at our concavities, you're looking for a cave up, a cave down. So here's a cave up. There's a cave up over here. Here's another cave up over here. Anybody see any more caves? Cave down. Good. And you see the sides they share? The sides they share will have an inflection point halfway. We'll call this D and E. Now remember yesterday I told you how to find the inflection? Find the x value. Take the x value for A, which is negative 3.536. The x value for C, which is 0. Add them and divide by 2. So this inflection point D should be what? It's 1.71. 6, 8, 1.768. Okay? Now, go to your, well, how about this inflection point then? What do you think that x value will be? Positive. Because this is symmetric across your y-axis. Now, to find your y value, go to your calculator. Do second calc value and put in negative 1.768. Stay with me here, guys. Negative 1.768. Find me your Y value. 375? Thank you. And this guy would be the same, wouldn't it? Okay, there's my inflection points. So I have an inflection point at D, which is negative 1.768, negative 68.375, and I have an inflection point at E, which is the positive of that X value, because we have symmetry. Everybody okay with the inflection point and why? Because the concavities are crossing. They're sharing the same side. So at one point, they're concaving up, and they say, whoops, concave down, whoops, concave up. They're changing, they're inflecting, they're changing their minds in the middle, kind of. So now, let's find your concave up. Concave up works just like your increasing, decreasing. It works off the X values, as the Y is concaving up or down. And we work through our inflection point. So concave up, what's the first segment? First interval. Negative infinity to my inflection point, which is negative, no, give me the X value, 1.768, good. So okay, then I got to concave down. I got to concave down from that inflection point to the other inflection point. And then the rest of the way, I'm concaving up. Concaving up from 1.768 to infinity. Okay. You get all that? That's a heck of a lot. So tell me about your graph, huh? Anything else we need to know? Pretty good, right? Do you have any questions? Well, you're going to use this tonight for homework. Tonight for homework. So, let's just go through a list of things that you need to make sure you tell me. First of all, I want domain and range. Okay, make sure you write this down. I want domain and range. I want you to describe, well, okay, that's just one thing, but describe before you graph. Describe what you need to see. Describe it. Sketch it. I want to sketch. Then put it in your calculator and see what your sketch, if it came close to what you were looking at. You're going to need your calculator to help you find your mins and your maxes. Find any mins and maxes that you have relative to their absolutes. Find your zeros. Find your increasing, decreasing. Find your inflection points. And find your concavities. How do we do it? You take the average between these two x's. The midpoint of this x plus this x divided by 3. Okay? Okay, so let me just tell you something about the homework, guys. Wait, just let me tell you something about the homework. You're only going to do half of it.